another extra video class. Today we'll look into polynomials, remainder theorem. Before I state the theorem for you, let's take a few examples and solve on this theorem. It's simple. The question comes like this. In most exams, like GPEB exam, JAM, your school exam, it comes like this. Find the remainder when this is divided by this. Most times they'll give you a linear divisor. This theorem works only for linear divisor. That is when x has a power of 1. Invisible power 1 is there. So to solve this, it's simple. There's a solution. Let's solve together. Let's solve this. Before we solve this, let's reflect on fractions. Some of us will know fractions, yes. For instance, I can ask you what is 9 divided by 2. 9 by 2 is going to give us 4. Yes. Then a remainder of 1. If you know maths very well, you know that 9 by 2 is 4 remainder 1. Yes. So this is simple. It's very elementary. It's simple. Now, what they are giving us is this. This divided by this. They are giving us to actually evaluate x cubed plus 2x squared minus 5x plus 3 divided by x minus 2. In this case, we have to use remainder theorem. To find remainder, always apply remainder theorem. So how do we do this? It's simple. Just ask yourself, what can you put as x over here? What can you put as x to make the entire divisor equal to 0? What can make here 0? Is it 3? 3 minus 2 is not 0. Is it 5? 5 minus 2 is not 0. So what makes here 0 is when x is equal to 2. So when we place x as 2, the divisor becomes 0. So that value of x that makes the divisor 0, use that value and plug in your polynomial and plug in your function given to you to divide. So when I put x as 2, I will end up having, I'll have this to be 2 power 3 plus, I'm putting all the x as 2. I'll have 2 again power 2 minus 5 into 2 plus 3. So if I evaluate this, it's simple. You can do it calculator, you can solve further. But it's simple. 2 cubed means 2 times itself in 3 places. That is 2 times 2 times 2 in 3 places, and that is 8. So I have 8 plus 2 power 2 means 2 times 2 in 2 places. That is 2 times 2, 4. That's 2 by 2 squared 4 minus 5 times 2, 10 plus 3. If I do the arithmetic, 2 times 4 is 8. So I have 8 plus 8, 16 minus 10, that's 6 plus 3, 9. 9 is the remainder. This is a simple application of remainder theorem. Just find what makes your divisor 0. Use it and put inside your polynomial. Let's take one more example on this. So perfect the theorem in your head. So quickly, I will give you another example. Find the remainder when 2x cubed plus 4x squared plus 2x plus 1 is divided by x plus 3. So, anytime you want to find the remainder when dividing a polynomial by a linear divisor, the best way is just to apply the remainder theorem, which is talking about you getting what will make your divisor 0. For me here, what makes here 0 is what? Is it 3? 3 plus 3 is 6. So you just find what makes here 0. I think it should be, if I just do my x plus 3 equal to 0, I have that x is equal to going over minus 3. It's simple. Once you can find what makes your linear divisor equal to 0, you just plug your x as that value. Whatever you have as the outcome becomes your remainder. So for those solving theory exams, you can just say let f of x. If it's theory exams, it's simple. Just do like this. Let f of x be the polynomial. That is 2x cubed plus 4x squared plus 2x plus 1. Okay, now the remainder is given at x equal to what? The value that makes the divisor 0, and that is minus 3. So f of minus 3 will now be taking all the x and putting minus 3 as all your x, just the way we solved in the first example. So that will be 2 into minus 3 cubed plus 4 into minus 3 squared plus 2 into minus 3 plus 1. Alright, so if I should solve the simple arithmetic, you can also use calculator to get this. Minus 3 to power 3 is odd number. I will have minus 27. Minus 3 times minus 3 times minus 3, that's in 3 places, give us minus 27. Times 2, I think, is minus 54. Now, over here, plus. Minus 3 squared, even. So minus 3 squared, the minus will go out, because the square affects the minus. Minus times minus is what? Plus. 3 times 3, 9. So I have 4 into 9. I'm not sure my 9. Well, yeah. So plus. Minus 3 times 2 is minus 6. Then plus 1. This will leave us with 4 times 9, 36. So minus 54 plus 36. What's the answer? Minus 18. Minus 18 minus 6 minus 24 plus 1 minus 23. Minus 23. And this is my remainder. So what am I saying? I am saying that when you have a function and asked to divide, we have something to divide by something, provided that your divisor is a linear divisor, all you do is find what makes your linear divisor 0. Plug that value in. What you obtain is the remainder theorem. What you obtain is the remainder, and that's what the theorem we're talking about. So briefly, I can just give you a theorem to summarize this class. When next we meet, we'll still refer to it. We'll talk more on this when we discuss factor theorem in our next class. For now, what I'm saying in a nutshell is this: the theorem is saying this. If f of x is a polynomial, then we have that f of x will be equal to a quotient. Let's say a linear divisor x minus a multiplied by its particular quotient plus the remainder. This is it, the summary of this theorem. Now observe something. Observe this. If x is equal to a, what happens? I'll have f of a. What would that be? If x is equal to a, that means I can put here a, and a minus a gives 0. So all this place, if I put x as a, all here is going out. So when all here goes out, I'll be left with just the remainder. If all here vanish because x is equal to a, I'll be left with my remainder. So when x is equal to a, I'll have remainder r, the remainder theorem. So whenever I put f of a, what will have is what? The remainder when s is equal to a for every linear divisor. Thank you for the wonderful extra class. My name is Holget Emmanuel. I hope the class was helpful. See you in the next class. Thank you.